Seccomp stands for Secure Computing Mode. It's part of the Linux kernel, a bit like much of the things we've been looking at recently with regards to security. So what does it do? What's it for? It's essentially just a way of sandboxing the privileges of a process so that we can restrict the calls that can be made from user space through to the kernel. It's a way of just locking down syscalls and things like that, basically, in a nutshell. So how does it work? Well, let's get into that in just a second. So how does it work? Well, in a nutshell, we write a JSON file out with a bunch of syscalls in, or what we are allowed to do and what we're not allowed to do, how we're going to log or error, things like that, and basically apply it via the security context. The JSON files live on the node themselves, a bit like the app armor profiles we talked about in one of the previous videos. Sounds pretty easy, so let's go take a look. We've got three here. We've got the audit.json, which the default action is this, and this basically says that any syscalls will be, the action is to log, so that's that. The default action of violation is to error out, and the fine-grained one is saying that the default action is to just error out, but these syscalls with these names are allowed as per this action. How do we apply these? Well, the kubelet is actually already configured, ready to go for all of this, but we will go ahead and go through the process of downloading those profiles. So I'm going to jump over to the terminal, and in here we'll go to cd var lib kubelet, and we need a folder in here called seccomp, and then in there called profiles. So we'll do make directory -p seccomp and then /profiles. Let's cd into seccomp, jump back over to the documentation here, and as you can see, make that directory and then curl these files. And as you can see, it's got the profiles / here, which is why I'm sitting in the seccomp directory. So I'll paste that in. We'll grab all of those, cd into profiles, ls, and we should have 3. There we go, audit, fine-grained, and violation. These are going on the control plane. We also need them on the worker node. So we'll go ahead and do the same thing over there. cd into var lib kubelet, and we'll make directory and -p seccomp /profiles. cd into seccomp, and then we'll copy and paste those in again. I'm just going to make sure I've actually copied them because of tmux funkiness. cd into profiles, list it out, and we've got all 3. Cool. So we've got what we need. Now we just go ahead and create a local Kubernetes cluster with kind. No, we don't. We don't do that because we're not using kind. We're using a different kind of cluster, which is kubeadm. So how do we do it on that? The docs don't tell us, but don't worry. I'm about to tell you now. This here is basically saying we're going to create a cluster, and with the control plane role, we're going to add that profiles directory that we created on our own machine to map it to this location. We don't need to do that because we've just created this directory on our nodes and dropped the profiles in there. So that's fine. We can skip this section here. The other thing I would recommend doing, honestly, don't actually know if this is required, but I like to do it just to make sure the kubelet rereads its root directory, which is the varlib kubelet here. I will do systemctl restart kubelet, and then I will copy that and drop that onto the control plane as well, just to make sure that everything is good to go. So next we can go ahead and create a pod that uses the container runtime seccomp profile. Now we have already done this once where we did runtime default. It was in the last video where we had the standards, and one of the standards was that it has to use localhost something or runtime default as a minimum. So we've actually already done this, but I'm going to go ahead and copy that. We will jump into the IDE, create a new file called seccomp.yaml. And in here, I'm going to go ahead and just paste that pod in. Now, as with all the other videos, we should already know what's going on for the majority of this because we've covered most of this. We have a pod with a name and a namespace, a label. We have containers. There's a test container. It's this particular. And yeah, we're making some more syscalls. So that's basically it. Security context in the container is to say allow privilege escalation false. And the seccomp profile has a type of runtime default. We've already done this in the previous video, but we'll go ahead and apply that. So do kubectl apply -f workloads extras seccomp, and if we go ahead and run that and describe, we'll see everything is fine. It's up and running. It's started. If we get that pod, there you go, it's running. And that's pretty much what it's going to get us to do here. It's just making sure that it's actually working. So we can go ahead and just delete that pod. We know that the default runtime is working, and we can actually configure the kubelet to automatically set this as well, so that it always sets this by default. But we'll look at that towards the back end of the video. Next, we'll take a look at the profiles that we've set up. So we're going to start off with the audit.json profile, which will log all syscalls of the processes to a new pod. So here's the manifest for that pod. So let's copy that. We will just overwrite the one we're doing now, and we'll stick that in the namespace, and that will be learning. And let's have a look. We have type localhost, a bit like the app armor one we did in the last one, where we have to specify localhost because that's where the profile lived. We have the same thing here where we're specifying the localhost as a type, and the localhost profile is profiles /audit.json. Now this will force the kubelet to look in the profiles directory of Seccomp, and that's basically it. So let's go ahead and apply this. So we'll do the apply command again. We'll do a describe command, and we'll see this has started. So let's get that pod, and we can see here it is running. So that's good. That's running, and that is starting. So now we go ahead and expose that. We just need to stick a namespace on that. I could have just done this in the default namespace. It's just I'm trying to stay in the learning namespace, that's all. And as we can see, that's now exposed. So if we get the service for that, namespace learning. And this port here is now exposed as a node port. So we can now jump onto the control plane. And if we jump over here, we can just do curl localhost and that port. So we can see here, just made some syscalls. Well, that's done what we want. It works. It's responding with that. And that's pretty much what they've just asked us to do here as well. So now we can take a look at the logs on that particular node. So we won't have syslog on ours because this version doesn't. Ubuntu 22.04 by default doesn't have our syslog installed, but you can use journal CTL. So if I do journal CTL, this is on the worker node, remember? In fact, let's just find the actual node that this is deployed on. So if I jump back over here, we'll do kubectl, get pod, namespace learning, and we'll output it as wide. We have the audit pod here, and it's on worker 2. So on worker 2, this is the one we need to focus on. So I'll do journal CTL. I've got my pane sync, so but it doesn't matter, it's fine. And I'll grep audit. In fact, I'll just grep HTTP echo in the same way. And if we just let that run, we should get an output here. There we go. So we've had a bunch of stuff outputted just there, and we can go back and read through the whole thing. But if we actually just take a look here, we can see pretty much what we were expecting to see here. So we have audit logs and com HTTP echo, the execute of it. So we can see all of that. And then it's got the syscall here. Tells us what syscalls have been made. We can see the syscalls that are required by HTTP echo by looking at the syscall entry on each line. As it says, these are unlikely to encompass all syscall users, but it can serve as a basis for a seccomp profile for this container. So we could then go ahead and write one that meets that requirement. Essentially, that's what it's saying. So all we really need to do is find out what the syscalls are for a particular process or command, write them into a JSON file, and apply that to the pod, allowing us to really restrict what that pod can do in terms of syscalls. So how do we find out what syscalls are used by a command or process? Well, one way of doing it is to use strace. So I'm just going to run strace wget. So we're going to do a syscall trace for wget. We'll just do it against google.com. We'll output that into temp.html, sorry, and we'll press enter. So I'm going to run that, and we'll see all of these syscalls here. As you can see over here, we have a few different ones all the way down here. So I'm just going to draw around them. There we go. You can see a bunch of them there. We've got IOCTL, get PGRP, write. There's close and all sorts down here. Look, there we go. So if I jump over to the browser now, we can see some of those are used. We have FCNTL, get PID, IOCTL, opener, socket, bind, write, and close there. So you can see here, these syscalls are there. They are listed in part of the syscall trace, and we can write a policy file based on that exact thing. Let's go ahead and delete that, and we will take a look at the next one, which is violation. So I'll grab that, we'll jump over here, paste it in, and we'll put it in namespace learning. And do you know what? I'm getting so bored of typing hyphen namespace learning every single time. I'm going to do something now that I've not shown you yet, but I'm going to do because this needs doing. So kubectl namespace learning, kubectl namespace learning, or kubectl config get context, and this is the name of my context here, and I'm going to set context, that name, namespace learning, and this has now made it so this is basically set this namespace here. If I go back and do get context now, my default namespace whenever I do a query is learning. It's just, it's such a time saver. It's minor time, but it's time when it all adds up. So kubectl get pod, look at that, straight into the learning namespace. Relief. Okay, don't have to type that anymore. Let's go ahead and apply this. So kubectl, apply -f, workloads, extras, and then seccomp. So we've created that. Let's go ahead and describe that. And we can see here, back off, it's failed. This is trying to do the same thing. It's just going to be doing an echo command. This is a default action of error if it's trying to do a syscall that is not allowed specifically. So by default, all of them are denied. That's what's happening here. And this violates it, but you can see here, there is a violation, pod learning, there we go, violation -pod underscore learning is the namespace. It's not gonna let it in, it's banned. You're not allowed in, you can't do it, okay? And we can see that here, and that's it. So that's that one. Let's go ahead and delete that. Let's jump back over here, and now we'll do it with the necessary syscalls. Take a look at the fine grain profile. You'll notice that some of the syscalls seen in the syslog, or in our case, the journal one, are set. And the default action is to error out, but we're also saying that certain syscalls are allowed. Let's go ahead and grab this one here, and we should find that this actually just works for us. One last time, namespace, learning. We're running that same one, but this time we're going to apply the fine-grained profile. The last time we obviously applied the violation one, and the time before that we applied the audit one. So let's go ahead and apply this. And let's describe this. We can see here, we've got it started. We'll do a port forward again, like we did last time, except for this one, we want to change that to fine pod. And we'll go ahead and curl localhost. And in here, we need to just have a look at what that was. So kubectl, get service, and it's this port we want. So we'll drop that port in. We've just made 3 syscalls. Finally, if we jump back over here, we've obviously applied it. We've got the pod. We've done a port forward, and we just need to basically check it over. So this is saying it to do a tail. We're not doing a tail, but we have already exposed the port, and we've got the port, and then run the curl command. So we got that response. And now this time we'd see no output in the syslog. So what I mean by that is let's find out what node this is on. So if I run this again, we've got fine pod sitting on worker 2. Okay, so I'll unsync those panes. I'll do generalctl-f and we'll get rid of this grep. So let's just go down a few lines and I'll do a curl localhost port. I didn't actually grab the port, did I? So I'll grab that port there, drop that in there, and there you go. So it's not logged it in the audit log. The response is working. So the security is allowed. So we've said that the wget stuff that's happening in the background, or the syscalls that are happening in the background for a better description, are allowed. They're not being logged to the audit log because nothing has been done that is disallowed, and we haven't set anything up to work with the audit log. We could change fine-grained to do an audit log instead of an error, but we don't want to allow the things that shouldn't be allowed, which is why we default to an error and then allow the syscalls we want to allow. Essentially, that's what's happening here. And yeah, finally, if we want to enable it for runtime default as the default, we can do that. All we have to do is set this here. And if we actually just jump over there and do a find for Seccomp, we'll see down here, we can have this. So at the moment it's set to false. If we set it to true, then it enables the use of this as the default for all workloads. So now when we run anything, it should use the runtime default Seccomp profile by default, which is defined by the container runtime itself. So container D, and that's just instead of using the unconfined or disabled mode. It just provides a strong set of security defaults while preserving the functionality of the workload. That's pretty much all it does. So yeah, it's possible that default profiles differ between container runtimes. Fair enough. You know, not everyone does everything exactly the same. Otherwise, you don't even need one program to do things for you or one app to do things for you. And then finally, if we just want to check it, we can just quickly run a pod. So we'll go ahead and do that. Let's just drop one in. And now we've got that, we can go ahead and grab this command here, jump back over to one of the worker nodes. I'm not sure which one it will be on, so I'll just run it on all 3. And here we go. There we go. So it's on worker 2, and you can see here that we have the profile enabled, and this is just the runtime default. So you can see all the things that are enabled by default. And that's it. That's basically it for this video. That hopefully gives you an idea of how to write a policy file for syscalls and how to apply them in security context. In the next video, we're going to take a look at audit logging and how we can enable that for our cluster so we can see exactly what's going on. So I'll see you over there.